Okay, in this section we will look at charging by contact and induction. So the first thing we're going to look at is what's called an electroscope, which is a device for detecting the presence of an electric charge. And there's two types that we will look at, and one of them is a metal leaf electroscope. That's this one up here. And the second one's a pith ball electroscope. So we have both of those, and I will show them to you in class, how we use them to detect charges. So we need to be aware of a pith ball because it's in our diagrams right now that we are drawing. So to charge by contact, contact means touching. So it happens when contact is made between a neutral object and an object that has a charge. So the first thing we will look at is how to charge an object negatively. So I will use the example of ebonite, and this is our pith ball, the second thing. It's important to always label everything in your diagrams so that whoever is reading them knows what you're talking about. So the ebonite, remember this is at the very bottom of the electrostatic series, is always negative. It takes in electrons from other objects. So I'll give it a lot of negatives and state that it's negative. So when I ask you to draw, I expect you to label it as well. And the pith ball will be neutral. So we're going to show that by 2 positives and 2 negatives and indicate that it's neutral. So when they touch together, electrons will move, and they are going to move from the ebonite into the pith ball. Looking for a different color here. And I'll use, oops, lost the pen, use some blue. So here I am showing that this is my, it doesn't matter if you count them or not. And I'm going to show electrons moving by just putting a little circle around them. So let's say 2 electrons move over. One here, and another one here. And I'll write words to indicate that that happens. So electrons move into the pith ball. From the ebonite. And this is during contact. So once you move the objects away from each other, they're both going to now have a negative charge. This is still negative. And now this is negative because it's now taken some electrons on. So it had 2. And just to show the electrons that moved, I will circle them to show that these are the ones that came over from the ebonite. So both are negative and repel each other now. So what are the key points in this? There's 2 things to remember. Number 1, the object being charged gets a permanent charge, as permanent as static can be. We will see in induction what temporary means. So I'm going to put that compared to induction. So we'll highlight that, that's important. And secondly, the same charge is given to the object being charged as the object at the start. So the ebonite was negative and the object in the end ended up being negative. That's what that means. So for example, the pith ball and ebonite are negative. Okay, so that is charging by contact. Next, we will see how to give an object a positive charge. So in this case, we will look at the glass instead, glass and pith ball again. You remember glass is at the very top of the electrostatic series and would always lose its electrons. So it's going to start off as positive. And again, the pith ball is neutral. So when they contact one another, electrons are the only things that can move, and electrons will move from the neutral pith ball into the glass. Now obviously this is a representation because there's a lot more electrons and protons in all objects. So electrons are transferred from the pith ball to the glass. As a result, now they are both positive. And they repel. I think I forgot to indicate in the last diagram that was happening. So these repel each other. So now they repel one another. So again, it's permanent and the same charge. Let's just go back 1 second and just see. Yes, I did forget that this should say repel each other. So fix that on your note. Okay, so that because they are like charges, they repel. And the same thing happens here when they're both positive. So what happens? Why do things repel? Well, this is based on the law of electric charge. There are 3 laws of electric charges that describe how 2 objects interact electrically when one or both are charged. So it's also known as the law of electrostatics or the law of attraction and repulsion. So this says that like charges repel, that opposite charges attract, and that charged and neutral objects attract. We will see some examples of why this happens, charged and neutral objects, when we do some diagrams. Okay, so the last type we're going to look at is charging by induction. So these past 2 are contact, right? So when objects touch each other, there's a permanent charge and it's the same charge as the original object. Now what happens with induction? So charging by induction means only coming close to the object. It means not touching it. The charged object is close to the neutral object. The charged object induces or causes electrons in the neutral object to move. So this is how a neutral object gets charged. An induced charge separation is the movement of electrons in a substance. And a temporary charge. So once the charged object is removed, the charge is gone. It does not stay. So that's what I meant by temporary and permanent. So let's take a look at, again, this is ebonite. And ebonite is negative. So we'll draw it as negative. Just need to have an imbalance of negative charges, more negatives. And the pith ball is neutral again. So as they get close, this is showing as they get close. So initially they're far away. Then as they get close, watch what happens to the charges. The positives are going to line up here, attracted to the negatives inside the ebonite, and the negatives will repel. So they've repelled, and the positives are attracted to the negatives. So it's an induced temporary positive charge on the surface of the pith ball. Okay, because the positives in the pith ball are attracted to the negatives in the ebonite, and the negatives in the pith ball are repelled from the negatives in the ebonite. So if you were to then pull them away from each other again, this is what would happen. So as you pull the negative ebonite away, the pith ball goes back to neutral, okay? So again, two key points here. Number one, the charge is temporary. As you pull it away, it no longer is charged. And number two, it's an opposite charge. So on the surface here, a positive charge was induced. It's opposite to the original negative charge. From original object. So opposite charge is induced from original object. So we could make it permanent, but that's for another lesson and another time. So from this section, I want you to do not 1 to 8, 1, 2, 4 to 8. Okay, so that's the end of this lesson. In the next lesson, we're going to look at applications of static electricity.